All right, so we have been looking at how to work with polynomial functions, but today we're going to start looking at how to solve them. We're going to look at how to solve polynomial equations that have a degree of 3 and even a degree of 4. So let's jump right in. In the last unit, we looked at how to factor when we had some special cases like sum of squares, difference of squares. Now we're going to look at sum of cubes and difference of cubes. And these formulas might look a little bit intimidating at first, but I hope that you'll see that they aren't too bad. Something that I want you to notice is that both of our terms have to be perfect cubes in order for this to work. The second thing is that the only difference between these formulas are these two signs right here. This last one, it's the same. And so I had trouble remembering which order the signs went in until somebody taught me about SOAP. So SOAP tells us that we do the same, the opposite, and then always positive. So what I mean by that is that this sign is the same as the one that we started with. This sign is the opposite of what we started with, and then the last one is always positive. So if you look here, we have negative and negative. They're the same. Here, though, the second one, they are opposites. But everything else stays the same. We've just got a and b, a squared, ab, b squared. So let's practice this. The first thing that we're always going to want to do is to find the a and the b values. So in other words, take the cube root of each of these terms. If you don't know your perfect cubes yet of like 1 through 10, like if you don't know that 7 cubed is 343, you're probably going to want to start memorizing those because it'll make this all go a lot faster. You can use your calculator, but your brain's faster than a calculator. So when I take the cube root of 8, I'm looking for a number that multiplied by itself 3 times gives us 8. I'm not doing 8 divided by 3. Please don't do 8 divided by 3. But if I look at 2, 2 times 2 is 4, times 2 is 8. So the cube root of 8 is 2, and then the cube root of x cubed is just x. The cube root of 1 is 1. So if I put this, I'm going to have my small set of parentheses and then my bigger set of parentheses. First, I just put a and b as is in the first one, 2x and 1. That's pretty easy. For the second one, I'm going to square it. And now, please notice that I'm putting this in parentheses, and I will show you why in just a second. And that middle term is just a and b multiplied together. Now, the reason I do this is because if people write 2x squared, they think that that's their answer. But we have to square all of a. And so if we square all of it, we're remembering that we have to do 2 squared as well, and not just the x squared. So when I fill in my signs, I started with a negative. So I'm going to have the same sign here. The opposite of negative is positive, and then the last sign is always positive. So this gives me 2x minus 1, 4x squared, plus when I multiply those, I'd get 2x, and then plus 1. And that would be my final factored answer. All right, let's look at another one. Try this one on your own. Start off by finding the cube root of the first term and the last term. So you should have gotten a equals 5x and b equals 3. And then go ahead and finish this off. What do you get for your parentheses? In the first set of parentheses, we'd have 5x and 3. In the second one, 5x squared, 3 squared. And in the middle, 5x and 3. And then we need to fill in the signs. So we'll do that. This started off as a positive, so we do the same sign, the opposite sign, and then always positive. So we get 5x plus 3. That would be 25x squared minus 15x, and then plus 9. And that would be our final answer. All right, so we're going to take it a step farther and we're going to solve it now that we are feeling good about practicing, hopefully, the factoring. we are going to factor this because in the last unit we looked at how to solve when it was just like x squared minus 4, for example. That's not going to work with this. We can't just subtract 8 and take the square root because we'll only end up with one of our 3 answers. And so let's look at what happens when we factor this. What do a and b equal? First of all, a equals x and b would equal 2. So set up our factored parentheses. What do we get when we factor? You should get x and 2, x squared, 2x, 4, and then filling in the signs, we started with a positive, so it's going to be same sign, opposite, always positive. Now this is where we stopped on the last two, but we're taking it further, and just like before, we are setting each set of parentheses equal to 0, just like we did in the last unit. So when I solve this one, that's pretty easy. I just get x equals -2. Woohoo! That was nice. But then I look at this one, and here's the problem. If I had taken the square roots, I would have got, or cube roots, excuse me, I would have gotten -2, but I would not have gotten these answers. I cannot factor this. Pretty much you're never going to be able to factor what's over here. We're going to get something different, and so we need to use completing the square or quadratic formula. I'm just going to go ahead and use we'll use quadratic formula. So x equals -b plus or minus square root of b squared minus 4ac, and then all over 2 times a. If I simplify what's under the square root, I get 4 minus 16, which is -12. And then simplifying that, because I know it's under a radical, I would have a 2 on the outside, 3 on the inside. So I'm going to get x equals 2 plus or minus 2i radical 3 all over 2. My final step is to simplify. Divide everything by 2. And I don't need to write divided by 1, so I'm just going to write 1 plus or minus I radical 3. I don't need to write the 1 in the denominator because I don't have to write when I'm multiplying or dividing by 1, but if I'm adding or subtracting, like with this one here from this simplified 2, I do need to write that one. So that would be my final answer, along with x equals -2. All right, it is possible for us to factor even higher degree polynomials. So I said at the beginning we were going to look at some quartic polynomials or polynomials with degree 4, and that's what we're going to do today. But we're going to use factoring. All right, so just like with factoring in the last unit, we're going to start with 2 sets of parentheses. And we say, oh, let's split up our x's. Only this time, instead of having only 2 x's to separate, we now have 4. And so to make it even, we're going to put 2 in each set of parentheses. So we're going to have x squared and x squared. Now, this last number is a 6, so same rules apply. 6, what multiplies to 6, excuse me, and adds to 7. 6 and 1. Same sign or different? And they're both positive. So this would be my final answer. If I was asked to factor it, I would stop right here. If this was an x squared minus 1, that would be one of our special cases where we could go like this and do x minus 1 and x plus 1. But because of this plus sign right here, we cannot do that. So this is our final factored answer, but just make sure you're looking out for that x squared minus a perfect square. It doesn't work in this case. All right, so we've been asked to solve this polynomial. To solve it, what's the first thing we're going to need to do? We need to get everything on the same side. So we have x to the 4th plus 11x squared plus 18 equals 0. And I'm going to split it up into 2 sets of parentheses. When you factor this, what do you get? We get x squared and x squared. What multiplies to 18 and adds to 11? 9 and 2. Same sign, both positive. I can't factor this one anymore, even though 9's a perfect square because of that plus sign. So I'm going to take each set of parentheses and set it equal to 0. All right, try finishing this problem up and see what happens when we solve for x in each of these. What do we get? Because there's no x term, we're just using the square root method. So subtracting 9, and we would get x equals plus or minus 3i. Over here, we would subtract 2 and get x squared equals negative 2. And x equals plus or minus I radical 2. I started off with an x to the 4th, and if I count them up, I've got 1, 2, 3, 4 answers. So I did something right. Let me know what's one question that you have about this video or about this lesson, and that will give us something to talk about together.